Welcome to WasmAssembly episode 9. This is a very special episode because we're not recording from home. We're not recording from a studio as it was the last two times, but today we're recording from the Google Developer Group DevFest here in Karlsruhe, Germany. Woohoo! So local time, it's almost 7 p.m. So people here have been sitting through an entire day of amazing presentations, one of them given by my special guest here. And today with me is Thorsten Hans, Senior Cloud Advocate from Fermyon. Welcome, Thorsten.
Yeah, thanks for having me, Tom. It's great to be here in Karlsruhe.
Thank you very much for joining. And you work at Fermyon as a cloud advocate, as a senior cloud advocate even. What does a senior cloud advocate do? Does he do different things than a cloud advocate does?
Oh, yes. So I would say cloud advocate is basically a role under developer relationships, right? So I think there are some common tasks that each of us does at Fermyon who is in that role that may, mean like speaking at conferences, recording podcasts as we do right now, or, coming up with new ideas of how developers could actually use our tech in order to build new things. And also to gather feedback from the users and, take that data and feed it into the engineering teams in order to make our products and services better in order to address the needs that all the people have there.
So products means things that you build, your company builds, and your company is Fermyon. Can you just very briefly summarize what Fermyon does?
Yes. So Fermyon is basically laying the foundation for using WebAssembly beyond the browser. So we're focusing on how to use WebAssembly to build software for the server or for the cloud in a distributed way, maybe thinking about microservices or serverless architectures. That's basically what we do. And that also means that we, build or contribute a lot to what we call upstream from our point of view, which is projects under, for example, Bytecode Alliance or in the CNCF, which is the Cloud Native Computing Foundation.
Nice. Before joining Fermyon, which is I think only a couple of months ago, right? But last February or something. I looked you up on LinkedIn, obviously. So before joining Fermyon, you worked at ThinkTexture, a local here to Karlsruhe consultancy. And you worked on cloud and WebAssembly. So this is, I guess, where it all started, or did you have a WebAssembly background even before that?
So, yeah, first of all, yes, you're right. So I joined Fermyon in February this year, so February 2024. And before that, I was working like almost a decade at ThinkTexture, where I mainly focused on helping developers to build software for the cloud. It is called like cloud native, whatever that means, right? That means different things.
So it means the same thing as serverless.
Yeah,
There's no cloud in cloud native, or
well, there may be.
the cloud that is there is native.
Yeah. So obviously I had some touch points with WebAssembly during my time at ThinkTexture from let's say the 9 to 5 job that I did there. But I got into WebAssembly and all that its ecosystem more in the spare time. So I started experimenting and I was, also using serverless services like, for example, Azure Functions, AWS Lambda, or Google Cloud Run, like 10 years ago already. So the idea of serverless computing was always appealing to me. However, the way how those services were built, or what they actually, or the disadvantages they had, were made me look into Kubernetes for the vast majority of my time at ThinkTexture. But then I stumbled upon Spin, right, which is one of Fermyon's projects. And so that got my attention, and I found myself, diving deeper and deeper into Spin, uncovering all the bits of WebAssembly. And, I thought, hey, this is something that could dramatically change the way we as software developers build software for like every environment. And it could be something like, let's say, the relationship between containers and virtual machines. And that's, how things started for me in WebAssembly. And at some point, there was the opportunity to join Fermyon, and I took that opportunity and started, yes, in February.
All right, so we will talk about Spin in the next couple of minutes. But before we go there, I just wanted to quickly realize that, oh, you are wearing a WasmIO shirt, and both the two of us were at WasmIO in Barcelona, and both the two of us will go, like when you hear this, it will be in the past, but for us, it's tomorrow. We will travel to WasmCon in Salt Lake City. So our paths crossed, even if we didn't know it before. So that's sometimes one of these nice stories that, yeah, you realize once you realize. And so, yeah, for Fermyon, I guess my first contact with Fermyon was through Till Schneiderheit. So very visible Wasm person, works for the standardization in the Bytecode Alliance. He is, I guess, pretty principal at Fermyon, if not one of the co-founders. I don't know. But like, he works very much on WebAssembly standardization. And Fermyon is one of the big implementers of WebAssembly, I guess, informs a lot of the decisions that get made in the Bytecode Alliance. So in your work as developer relations or the cloud advocate at Fermyon, is this like standardization? Is this something that you are also co-responsible for? Is this something you contribute to? Do you give implementive feedback when it comes to, oh, we need a standard position from the industry?
That's a good question. So basically, everyone at Fermyon can contribute to upstream or, assist in defining new standards in order to meet the requirements that people actually have. Personally, I did not contribute to standardization specifications up until now, but this is mainly because I was, uh, responsible for other things that are more like uh, targeting our existing user base and trying to transport or trying to tell developers what they actually can build with Spin, for example, with SpinCube or Fermyon Cloud, to name just a few of the projects and services that we offer as an organization. So yes, everybody is allowed to contribute to upstream. That could be like Bytecode Alliance or projects under the Bytecode Alliance, like for example, Wasm Time, to name just one project there. That could be specification or doing specification work, but that could also mean like making more languages actually compiled onto WebAssembly. That's also what we consider as upstream work, because our main target is to make WebAssembly something that every developer can use with ease without, having to know that many different things about all the language idioms.
Hmm. Makes sense. So let's talk about Spin a bit. So Spin is obviously a product. Fermyon is a commercial company, so there's some money to be made. But Spin is also an open source project. And if I go to the website, it says Spin is a framework for building and running event-driven microservice applications with WebAssembly components. So there's a lot of things to unbox here. So first, what are microservice applications? I only heard of microservices, but never of microservice applications. And then what events drive them? So can you just help us unroll this a bit?
Yes. As you said, that statement is a mouthful, but I want to quickly reiterate or the first sentence. So Spin is a project. Yes, it's an open source project which we contributed to the CNCF. So there is no product in Spin. Spin is open source. It remains open source. And we have many contributors from outside of Fermyon as well. And so your question was microservice applications, right? Was that what we mean
Like,
by?
what is microservices versus what is a microservice application?
Yeah, that's a great question. So basically, um, a single microservice does like one thing, which it actually does pretty good, right? However, to have like a full-fledged application, you may need more than just one service. And by relying on the WebAssembly component model, we can, draw a whole different picture of how you implement and design, like, let's say, microservices or architectures based on microservice, right? Because you can quickly use, or you can basically use that programming language that helps or that makes you solve the problem in the most efficient way without, starting over again. You don't have to do a new GitHub repository, right? A spin up is or consists of multiple components, and you could choose different language for each and every component. So itself, each component could be a microservice that's deployed on its own, but it could also be composed together, that we have like 3 microservices in one distributable unit, which is ultimately like a WebAssembly module that you deploy to some sort of runtime.
Mhm. So we will go into the events driven in a bit, but I guess when you say open source and product, so I guess is it the service that you're selling then, the Spin Cube? Is that the business model, or like how does it work?
Yeah, every organization has to be sustainable in some way, right? So SpinCube is also open source, and is also we also contribute that to the CNCF. And SpinCube, that's also pretty important, is not just made by people at Fermyon, right? That is a joint effort from people at SUSE, Microsoft, Liquid Reply, and us. And in the meantime, a lot of community contributors jumped on SpinCube and helped on implementing new features. So Spin and SpinCube are open source repositories or projects that we contributed to the CNCF. And we have Fermyon Cloud, which is a fully hosted cloud service that we provide where you can deploy your spin-ups and run your spin-ups without having to, manage infrastructure or worry about the underlying database being available. That's something we take care of. And on the other side, because we want to meet the customers or users where they are, which is obviously most of the time Kubernetes, that's why we build on top of open source SpinCube, we build Fermyon platform for Kubernetes, which allows you to run in an even or in a higher density mode as you could do it with open source SpinCube.
Got it. Nice. So let's talk about Spin a bit more. So Spin, one of the selling points is that you don't really need to keep your applications around because they have a cold start time of just a few milliseconds. And that's a pretty impressive statement, especially if you think of what was cool before. So earlier in your talk, you mentioned like there was this moment when the industry celebrated 200 milliseconds, which is pretty quick, but of course not quick enough in many cases. So you mentioned Internet of Things as one of the use cases. So several or like few milliseconds, that's pretty fast. And that's actually one of the reasons, I guess, why it's attractive for people to build on something like WebAssembly in the context of applications that need a fast startup time. But like, can you summarize how does it work? Why can it be so fast? Why can it cold start so fast? And how does it then handle multiple concurrent requests?
Okay. Yes. So first of all, I think let's talk about concurrent request handling, because obviously threads are still a topic in the WebAssembly world, right? That's under active development. So there are no threads in the WebAssembly, let's say, guest codes or in a Spin app. So we took like our Spin is written in Rust, and in Rust there is Tokyo, which is a crate, like a package that you can use to build your applications, and they have the concept of tasks, which are basically green threads, right? That we can use to concurrently react to multiple or to react to concurrent requests on the runtime level, and then we spawn the guest module, so your application, right? Um, so the code that you write is compiled down to WebAssembly into a WebAssembly module that is ultimately a WebAssembly component model. Um, that basically aligns to the WebAssembly component model, and the underlying runtime that it loads basically the Wasm file from disk, adds what we call host capabilities or factors, and we can talk about that in a second. to the WebAssembly runtime. So it adds them to the linker, and then the WebAssembly module is instantiated and invoked. So due to the nature that those WebAssembly modules are super tiny in size, it all boils down to I/O being the bottleneck at some point for that cold start performance, right? So we can only cold start an app as fast as we can read it from disk, which is the worst case, right? In SpinCube or maybe in Fermyon Cloud or in Fermyon Platform for Kubernetes, we obviously cache applications or WebAssembly modules in memory to, start them even faster. But at the end, we have to read the bytes, right, and instantiate. We have that WebAssembly runtime, and so we have to invoke the guest code.
Yeah, talking of the guest code, so Spin, like classic WebAssembly, supports the classic WebAssembly supported languages. So we have Python, we have .NET, we have Rust, we have Go, and so on. We have JavaScript, TypeScript, and in the last episode we had Steve Manuel from the Ellipso on, who's the developer of XTism. But my understanding is, because you mentioned the WebAssembly component model, you mentioned WASI several times, that you're not using something like XTism, but you're using the component model and WASI directly.
That's right. So personally, I was using XTism like 1.5, 2 years ago, to get an understanding of what is this project capable of. But in Spin, we so all our apps result in being WebAssembly component modules, and those basically, in the case of HTTP being the trigger, right? All they have to export is the WASI HTTP incoming handler. And this is also, boils down to us working on standards, right? So you can write your Spin or your app with Spin, compile it down to WebAssembly, and then run it on any WebAssembly runtime that is able or that is built on top of WASI. Obviously, we have some. So Spin gives you a lot of capabilities or features that developers use on daily basis. Like, for example, reading configuration data, interacting with, let's say, database, or reading and writing to key value stores, right? So those are capabilities that are sometimes available. Sometimes there are WASI specifications or WASI words available for those capabilities, and sometimes not, right? If they're not available, then let's say we take the lead, we implement our idea how, for example, let's say, reading configuration data could work, right? And we create a WIT, so WebAssembly interface type, which is basically, so we write a WIT world that describes how or which capabilities should be there. And I think config is super straightforward, right? You want to allow developers to read a config value. So we may be, or actually we came up with a world that allowed you to read config values. But then, the specification took place and we now have WASI config. So at some point, we adopted WASI config and faded out our Fermyon specific implementation and interface. But if you want to take an existing Spin app and run it, let's say, on Wasm time, bare Wasm time, all you have to do is you have to ensure that you add those capabilities to the WebAssembly runtime that your app is actually looking for. And this makes it, super portable, not just across like those obvious WebAssembly benefits across operating systems and architectures, that makes Spin apps portable across different runtimes as well.
And this is then, I guess, where the SDKs come in. So you have SDKs for various languages. Before we go into this, so the trigger concept, one moment more. So you talked about HTTP request as a trigger, and I guess then you work with the WASI HTTP API to make this happen. What other triggers are there?
We have, obviously, HTTP was the first one, right, to unlock a vast majority of scenarios. But I think pretty early in Spin, there was also PubSub, so you could trigger WebAssembly module or Spin app based on messages appearing in Redis in that case. So if one part of your distributed app publishes a message, Spin could trigger another app for every message appearing on that channel. We have a so-called command trigger, which is super interesting if you use or if you deploy your workloads into Kubernetes, because that one is like the fire and forget trigger, right? It executes your guest code once to completion, and it also terminates itself, so the host, once your code has been completed. And this allows you to basically run jobs and cron jobs on Kubernetes using WebAssembly, because it behaves like a traditional program that you execute until the process is done, and then you get an exit code, 0 indicating success and everything else indicating a failure. So command trigger is super popular these days. We have triggers for SQS, we have triggers for Kinesis, we have a cron trigger for scenarios where you may not run on Kubernetes. Maybe you want to run on bare metal and you want to use Spin as a runtime, or you roll your own runtime. And I think on top of that, the interesting bit is that you can add new triggers without changing the code base of Spin itself, because we have like a plugin ecosystem. So everyone can contribute new triggers without, diving into Spin source code. That much. Obviously, you will consume some of the existing code, but you don't have to modify like the core Spin project to do so. And actually, the Kinesis trigger has been contributed from the community, so from outside of Fermyon.
Oh, nice. Cool. So I'm most familiar with JavaScript, and JavaScript, of course, is also something that is very interesting in the browser. And like this is like Fermyon is obviously a server company, but the concepts here are interesting as well, just in general, because I looked at this guide that you've published on the website. We will link to it in the show notes. Building Spin components in JavaScript, and so components can be built in any language that compiles to WASI. JavaScript, TypeScript is one of them. But in the end, JavaScript is an interpreted language, which means in your SDK, you need to ship a JavaScript runtime, right? And you use from the Bytecode Alliance an adaptation of componentize.js, and this is where the browser then comes in. If you want to run JavaScript code that you don't know where it comes from securely in your project in the browser, this is a similar approach that you could take. You can take a JavaScript engine, compile it into WebAssembly, and then run it in a WebAssembly sandbox. So you're doing essentially something like this, but on the server as well. And that's what I said. The concepts are mostly interesting and the same. So componentize.js from the Bytecode Alliance uses SpiderMonkey. But then when I read up on how you do it, you use StarlingMonkey. So not Starlink, StarlingMonkey, which is based on SpiderMonkey, but it's optimized, I guess, for the faster startup times and so on. Can you just tell us, like, what was the journey to getting there? There's obviously also Quick.js, which some of you may have been using in a WebAssembly context. Like, how did you get to StarlingMonkey?
Yeah, this is a great question, and I think we will, start by uncovering how our so right now, old JavaScript SDK looked like and worked. So we were using a Quick.js, which is like a runtime that implements just the JavaScript spec to run or to make JavaScript run or compile onto WebAssembly.
So when you say JavaScript spec, it means there's something like stream, something like fetch would not be included, because those are specified not in ECMAScript, but in the WIC.
Right. It was just the JavaScript spec, and it was lacking things like the fetch API or like APIs under the umbrella of service worker, right? And in order to, bring in the capabilities that were used or that people using different or languages other than JavaScript or TypeScript, we used a project called Jerry from the Bytecode Alliance, or JV, which was basically allowing us to extend and to add new capabilities. So that said, we came up with a bare metal, let's say, implementation to support fetch, but it was not spec compliant to the fetch API, right? And also we had like a hard time in bringing in language specific bindings for arbitrary with words, right? That was not supported back in those days. So then, I mean, you mentioned Till. So Till and others from our team and others from Fastly built StarlingMonkey on top of SpiderMonkey. So SpiderMonkey, like the runtime from Firefox, like let's say battle tested, used by millions of users, that was laying the foundation. And then they built StarlingMonkey, where they implemented, or which basically gives you like the fetch API, a spec compliant fetch API, and those capabilities provided or specified through the service worker efforts. And so this allowed us to use componentized JS in order to generate language specific, in that case JavaScript, bindings for our with worlds, right? Which made it like a first-class citizen. So if you right now start a new Spin project, and you mentioned obviously it's jittered, right? JavaScript by definition. How could we then take your JavaScript source with your dependencies and compile it down to WebAssembly? And this is, I think, that was one of the most like interesting aspects to me personally, how that works. And that was absolutely mind blown in the first place when I read that up, how that worked. So basically, during compile time, so when let's say you started your app, you implemented your Spin app, you pulled in your dependency like an npm package, and then you say, hey, Spin build, which takes your source code, compiles it down to WebAssembly. In the case of JavaScript, we basically bootstrap the runtime, we load all the dependencies, and we load your, let's say, user code. And then the global scope of that JavaScript is evaluated. And then we take a memory snapshot and write that down to ultimately become the .wasm file. So obviously, yes, like JavaScript-based apps are bigger in size compared to WebAssembly apps written in different languages. But if you just think about what happens on a recovers, that's amazing, right? Because the engine is, let's say, warm at that point in time when we snapshot it, right? So for every invocation of this Spin app, the engine or the runtime doesn't have to load all the dependencies. They are already there. All your constants are already evaluated. So the runtime could just invoke your user code immediately. And that makes it super interesting because with that approach, I mean, it's not unique to JavaScript. Python is the same, right? With that approach, you can use an interpreted language, but it starts faster when you compile it to WebAssembly, which is like from a pure tech perspective, that's super amazing.
It is amazing. And so I'm a browser person at heart. So there's this joke that Thomas Steiner told in one of the last episodes. WebAssembly is neither web nor assembly. But so it is obviously something that you can use in the browser as well. So I want to just connect to the browser people listening to this and watching this a bit more. So if I were to build my own stackblets or my own REPL.it or something, could I use StarlingMonkey? Is this something that could run in the browser, or is there just some heavy like node server kind of dependency? Is this something that you could answer at the top off the top of your head, or is this like the details would, I guess, then be in the devils? The devil would be in the details this way around.
That would be a great question for Till, right? So because he was so like deeply engaged into actually making StarlingMonkey a thing. So to be honest, I don't know. I can't answer that out of my head from top of my head right now. Um, but that's definitely something where he knows the answer like within a second.
Yeah, it would be interesting to get maybe Till, maybe someone from maybe Stacklets even on the show and discuss this, how they manage to run this. So interpreted languages running in the browser is a very interesting topic. So we have, for example, the WordPress playground that runs WordPress in the browser, which means they need to spin up PHP, run PHP in the browser, and I guess there the same concepts, the same optimizations, like you instantiate everything, and then you just put that thing into the memory image could apply as well. What do you think?
I'm just thinking about so if you stick obviously with the WASI APIs that are implemented in the browser, there's I don't have a reason top in my mind right now that would prevent the app from actually working. Obviously, there's an overhead because there is already like a runtime in the browser around you. But still, I mean, there are ways to optimize the resulting .wasm file to basically strip away things that you may end up not using or not needing. Um, yeah, but it was just my thought, or that came up in my mind when you explained the concept. So yeah, I think it could be possible, but to be on the safe side, I would
Definitely a
follow
rabbit
that one.
hole. Definitely a rabbit hole to
Yeah.
go into another episode. So you mentioned when you said JavaScript versus, for example, Rust, there's a size difference. It sounds like there could be at least a speed difference. So you make this promise of few milliseconds. I guess launching what has been a JavaScript compiled WebAssembly application is still a little bit slower than launching something that was written in Rust, for example, from the start. Is that intuition true, or what would you say?
Yeah, that intuition is true. Yes. So Rust is like obviously or will be one of the fastest languages that you can use in order to build WebAssembly workloads. Nevertheless, I think the performance is still like amazing. So you briefly mentioned my talk already. So I was demoing JavaScript because the vast majority of the audience has some experience with JavaScript over here at the conference, and it's yes, there is an overhead because you have to ship your runtime as part of the WebAssembly module, and still, I think it is worth comparing it to like a non-WebAssembly performance instead of comparing like languages between each other when they are compiled to WebAssembly, because I think uh, the actual requirement should maybe, you know, lead to the programming language that you use to solve that or to address a problem, right? So, for example, in Python, right, there are so many scenarios that you would default to Python where you would have, or where you end up with writing way more code in different languages. Um, so obviously, it's something you could gather metrics on, gather data on, and then act on those data points you get through by simply doing a POC, right? So for short-lived workloads, I would still say that JavaScript compiled down to WebAssembly based on StarlingMonkey is faster than it is natively. But at some point, like the native runtimes that we have, like Node, for example, right? For longer running workloads, for intense compute actions, they will at some point outperform like that in, additional layer that we have.
Hmm. Which, yeah, does make sense given the years and years and years of experience optimizing those. Um, it's a very interesting topic. We could go on and on, but it's getting late here, so I just want to finish with one question, and it may be a little bit of a provocative question, but I like asking those. So you said Spin is an open source project. It's a product, if you will, but it's like open source. So let's say I buy into that and I build my entire application, like my microservices application that is event driven, on top of Spin, and I use your cloud to host it. So I use your paid services. There's some integrations that you offer. So there's SQLite that you host. There's serverless AI that you now offer. And at some point, I realized, I actually want to do it myself. I want to host it myself. How easy on a scale of 1 to 10 would it be? Like, what are the caveats here? What is the things that you not necessarily maybe tell a customer in the first meeting, but then maybe in one of the close to the signing moments meeting?
So there's like the consulting answer, right? It depends. As time to, yeah, I mean, I had to bring that at some point during that episode. It No, to be honest, it depends on what your app actually does, right? So I briefly touched on like host capabilities, or how we call them right now, factors, like basically functionality that Spin provides on the runtime level that you can then use or call into by, for example, using, let's say, the Spin SDK for Rust. Or
So just 1 second, when you say runtime, this is the Wasm runtime, Wasm time.
right. So Spin itself brings its own runtime that's based on Wasm time. Obviously, we add like capabilities to Wasm time that we think are super awesome to have when you build like serverless or reactive applications. Like, for example, talking to key value store, or you mentioned serverless AI. Maybe you want to do an inferencing call and, you know, call our beefy GPUs that we run as part of Fermyon Cloud. So if you use capabilities like that, we always shield or implement them behind either WASI standardized specification, or behind a with definition that we created. So with Fermyon colon something word, right? And you can move not just from Fermyon, so you can move from Fermyon clouds, for example, to SpinCube if you decide, hey, I want to roll my own Kubernetes cluster and I want to run that workload over there. So SpinCube supports obviously a lot of triggers that Spin is able to use to call or to invoke your app. And on the container, the shim is what's basically used under the covers to run the workloads instead of spawning containers. That one spawns your Spin app, and that is obviously per release of SpinCube pinned to a specific version of Spin. Like, so if that Spin version, is already able, so it is, let's say you use a recent version of SpinCube, then you will also have like a recent version of Spin under the covers of the runtime that can, for example, do LLM inferencing. And this is like a super common scenario where users start from scratch. They write a simple app, right, that does some HTTP API, maybe exposes some endpoints. And at some point in time, you do, large language model interaction where you do an inferencing. Then regulatory compliance happens from time to time, and you are asked to, take your workloads and bring them on private infrastructure. So this is then obviously at that point in time where you may say, okay, I will take my Spin app, run that on my own Kubernetes cluster. So you deploy open source SpinCube there, you bring your Spin app, and instead of using our fully managed database in Fermyon Cloud, you roll your own, let's say, Postgres container, or maybe you have a Postgres cluster laying around somewhere, right? So computation happens locally without changing anything. Storage will be moved obviously from the cloud to on-prem. You have to provide like your connection string or maybe a token to access your database server, and somehow, I mean, not somehow, so you have to extract or back up the data from Fermyon Cloud, restore that backup in your Postgres database running on your own metal. But the question remains, how do you deal with that AI inferencing call, right? So we have a strict separation of the application logic and configuration aspects. So you can just provide a different configuration file that could, for example, tell the application, hey, you can do AI inferencing using Llama 3 chat, for example. And instead of calling it directly, like in Fermyon Cloud, invoking our beefy GPUs, or on your local laptop using Candle to do the LLM or the AI inferencing using your CPU, you can say use remote HTTP. So you can still have all the goodness of that AI inferencing happening in Fermyon Cloud, and which leads to like a hybrid architecture. So this is obviously something I saw a couple of times over the past months. So this is like on a scale from 1 to 10, I would say it's like, if you're the developer, it's like a 1, because ops will take care of Kubernetes.
Sorry, one is hardest or one is easiest?
One is easiest because sorry. Yeah. So because from a developer's perspective, you don't have to do any change to your application code, right? You just take your spin app. They are distributed as OCI artifacts, and you ask your ops team to deploy SpinCube to your Kubernetes cluster. So they have some work, obviously. But you can move your app right there. So if you now want to use a different story to do that AI inferencing, you could implement your own LLM factor. So we have like many factors in Spin, and LLM or AI inferencing is just one of them. So if you're cool with our way of how we implemented it, you can use ours. If you think, hey, I have a smarter way, or maybe a way that is compliant to my circumstances, then you can implement your own LLM factor and roll your own runtime. That's also possible.
So it depends. You could just have said it depends. Come on. That's such a long-winded way of saying it depends. I'm kidding, of course. Yeah. The question was on purpose provocative because there's a lot of companies out there who say yeah, we're providing the project open source, but then the service is so tightly coupled that you can't easily unlock yourself from the service. But I mean, that's also just a fair business decision. I just wanted to get a feeling of how Fermyon thinks about this themselves. And this brings us to the last part of the show, which is Wasm, but not. And it's always two questions. The first question is, when you instantiate streaming, so this is where the Wasm comes in, instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to?
So, yeah, we had a brief talk before recording this episode already. Before I told you I'm so super boring when it comes to streaming, right? So I think it like 3 years ago, it started slowly but continuously progressing that I default to YouTube and watch things like Primeagen or all those like famous streamers to just, have that playing or streaming besides. That only works with my wife, and the kids are not at home. They have other plans on streaming. But personally, so I use like my go-to stream is, if I know, okay, you have to sleep right now because you have to get up early tomorrow morning, it's Big Bang Theory, because I can talk through all the episodes out of my head. Yeah, I think like the best one I rewatched recently was House of Cards and Game of Thrones, because I love them. And yeah, I watch them like people do with Die Hard during Christmas season. You have to do it once a year.
Just Christmas movie.
Yeah.
So yeah, nice. I'm a big Big Bang Theory fan on planes because as I said, it's like it starts to get repetitive a little bit, and then you just slightly doze away.
Yeah.
Cool. So my last question is then for you: if there's something that you could local get, as in something that you do, and then global set, as in something that you wish everyone else did, and everyone is of course a flexible concept here, what would it be?
I I don't know if that's something that I would globally set, but definitely a local get that I established recently, like last 6 months or so, is I was used to use like Amazon Kindle for reading when I'm on the go, right?
Mhm.
But at some point, I swapped over and used like Apple Books or however that app is called, like, that comes with the stock iPhone.
iBooks.
Whatever, right? I use that app that is there on by default on my on a newer Apple device because they give you like a streak, right? If you read like 5 minutes every day, you get a new it makes a similar sound to the Apple Pay sound, that bing. So similar to that one, right? Um, and I try to at least read for 5 minutes a day. I mainly read like tech related books, but that gave me exposure to so many different things because at some point, I mean, you got tired of reading like the 10th book on, let's say, JavaScript. You may also get tired reading the 10th book on Go. So you start, exploring different like languages, like services, and you just briefly, spend some time reading that. And that yeah, deepen or help me to explore new concepts and to often challenge like things that were so like idiomatic to me, right? So for example, if you ask everyone out here, hey, if you do a new JavaScript project, how do you approach that, right? And I guess everybody has his or her way of doing that. But by exploring different languages, different tools, right, you may discover new ways of treating things. So that's something that I discovered super valuable as a local get, what I get used to and established a habit over the last, like, say, 6 months. Yeah. Um, but I don't know if that's something I would globally set. Uh, but I think in our domain, in our industry, it's super valuable to stay current and briefly skimming through books or maybe even how's it called? If you're on Amazon, you can ask for what is it? Die Leseprobe? Keine Ahnung.
We can just cut this.
Yeah.
All right. Yeah. So definitely we can generalize this. Reading more would definitely not hurt. Learning more would definitely also not hurt. And if you are the PM working at Apple iBooks, you've just made someone really, really happy by saying this blibbing sound that you get when you finish a reading streak. Is something that makes at least one user really, really happy. So I guess Steve Jobs was mentioning like 3 different people who were sound designing that particular sound when he was still around. So thanks for noticing. I guess you just made someone really, really happy. Right. So people who want to follow you on any of the social networks, if you use them, how can they follow you? What is your preferred way?
Yes, so I'm using like X, Blue Sky is something I recently jumped on that hype train, so to say. And it's always like Thorsten Hans, so first name and last name, just I'm out there.
Thorsten with TH or Thorsten without TH?
That's always a difficult thing. It's with an H, but the H is not pronounced. So yeah.
All right. Thank you very much, Thorsten, for being my guest on the show. Thank you very much. In the audience, let's give one last round of applause just to yourselves for listening so late. And then, of course, thank you everyone watching and listening to this online. And with that, yeah, happy next time. See you. Bye bye.